Johnson is a master's student. No. Amber Johnson is a master's student with the Michigan State University in the Aquatic Animal Health Laboratory under the guidance of Dr. Tom Locke. Her thesis focuses on infectious diseases affecting Great Lakes lake sturgeons. However, today she'll be discussing work she's been doing to advance our understanding of whirling disease in Michigan. So take it away, Amber.
Wonderful. Thank you so much for the introduction. I'm super excited to be here today. And first of all, thank you to the organizers for putting this opportunity together. So if I've had the privilege of sharing my work with some of you in the past, you may recognize me as the lake sturgeon disease girl, which, while it's a niche I happily occupy, is not what I'll be talking about today. So my thesis research focuses on novel virus recovered from Great Lakes lake sturgeon, but today I'll be shifting gears a little bit and talking about a problematic fish parasite with the complicated history in Michigan. So why did I undertake this project? Well, in 2021, I applied for and was awarded the Janice Fensky Excellence in Fisheries Management Fellowship. And this fellowship was created in honor of Jan Fensky, pictured here, who's the first female fisheries biologist within the Michigan DNR. So as part of this fellowship, I was first awarded travel funds to attend conferences and DNR management meetings. And I was also tasked with developing a project proposal that addressed a critical agency need. So to develop that proposal, I teamed up with Gary Whalen with the Michigan DNR and Dr. Tom Locke with the Aquatic Animal Health Lab here at Michigan State. And the agency need that we identified and focused on surrounded whirling disease. So the project I took on was aimed at piecing together the over 50-year history of whirling disease in the state of Michigan, with an eye towards arming fisheries managers with a compendium of information of this parasite in the state. So for the next few slides, I'll be bringing everyone through some parasite biology, geographic range, and ongoing relevance before diving into the specifics in the state of Michigan. And to start, whirling disease, as many are familiar with, is caused by the myxozoan parasite Myxobolus cerebralis. And it's a disease that affects primarily juvenile salmonids, where it has a tropism for the cartilage before it ossifies to bone. Some of the disease signs are blacktail, pictured here, spinal deformities, and fast twitch circular swimming or whirling behavior, hence how the disease got its name. So here I'm showing you why some of those more neurologic signs manifest. This parasite, which is the little round alien looking guy right here pointed with the arrow, and you can see it all over this picture in various parts. Let me get my pointer going or not. All right, here we go. So this guy right here. So you can see that this group of them was really eating away at the cartilage here in this image. So the story of whirling disease is interesting from start to finish, but I'll take it from the very beginning, where in the very early 1900s, certified disease-free eggs from the United States were sent to Germany. Soon after, the German facility began to see mortality in those US origin fish, and further investigation led to the discovery of Myxobolus cerebralis as the etiologic agent and the discovery of whirling disease. So further research uncovered that this parasite was likely endemic to Germany, and when naive and what we know now are very susceptible fish were brought over there, it did some pretty serious damage. So over 5 decades later in 1956, this parasite was found in a Pennsylvania hatchery, and it's believed to have gotten its way into the United States via the transport of frozen or live infected fish. So before I get into how this parasite made its way through the US, I want to bring everyone through the life cycle because it's critical to understand that before understanding how it disseminated throughout the population. And early hypotheses suggested that this parasite could be directly transmitted from fish to fish. However, eventually discovered that it was much more complex than that. So in brief, the fish released these myxospores, which then infect the intermediate host, a tubifax worm, and the worm releases these actinospores that are then infectious to the final host, which are salmonids, like I mentioned before. And so this cycle repeats itself in the natural environment. So you might be thinking, man, with the life cycle that intricate, this parasite must not spread very fast. And that would be very valid in theory. However, this intermediate host is widely disseminated across the United States. And not only that, the host is very resistant to a series of abiotic and biotic factors. So looking again at geographic range, as of 1956, this parasite was only believed to be in Pennsylvania. And even so, it was believed to be largely localized to a single hatchery at this time. However, as decades went on, through a combination of the unknowing possible transfer of infected fish and the fact that this intermediate host was established all over the United States, the parasite was quickly disseminated throughout the country. And with that, the parasite is considered reportable in over half of the US. And while I acknowledge that reportable means different things to different states, what I mean here is that when or if whirling disease is detected, at least one management agency in the state needs to know about it. So how did whirling disease get into Michigan specifically? So before I start talking about what I found through this project, I need to set the stage a little bit about what the situation with whirling disease first looked like in the state. And it all started in June of 1968 when fish were transferred from an Ohio facility to a Michigan facility. In July of 1968, the Ohio facility found out that their fish were positive for Myxobolus cerebralis. And unfortunately, it was later learned that the fish that had been sent there to the Michigan facility had also been positive, and it was now disseminated throughout this Michigan facility. So again, unfortunately, by the time it came to light that these facilities were grappling with the disease, the Michigan facility had already sold fish to 2 other farms, and testing revealed that now all 3 of these facilities were grappling with the disease. So restraining orders were put on all facilities and they were told to close. And I say told to close because there was a little bit of a legal mess surrounding all of this situation, but I'm not a lawyer and I don't have all of the tools to tell you all of that, but I will tell you that this didn't go over great with the private facilities at the time. So following that first detection, Michigan DNR set out to conduct some surveillance of wild streams downstream of where the infected ring facilities were. So the first set of collections happened in 1968, just after the detection. And with that, one fish at one of the 2 sites was found to be positive. And it was actually thought that this individual fish was a hatchery escapee, given that it was a rainbow trout and there were no resident rainbow trout in that stream. So that didn't really bode well for further surveillance, because when they set out to sample more sites along the river, it was found in 5 additional sites. And at this point, it wasn't only found in a single hatchery escapee, rather it was now found in resident trout populations throughout the river. So they also set out to sample river tributaries or offshoots of the river. And luckily at this time, the parasite wasn't in those tributaries, but this did prove to be a relatively small victory in the grand scheme of 50 years of detections. So with this, the first and only peer-reviewed publication regarding the prevalence of whirling disease in Michigan was published. And I want to highlight that this publication came out 50 years ago, almost exactly. And this is the only publication as of now that really details the prevalence and detection events of whirling disease in the state of Michigan. All right, so we had those detections summarized in 1972. Oh, spacebar stopped going. Hang on 1 second. There we go. But we didn't have anything really following that. So that left this 50-year gap where we had the information there. We had things that had happened like detection, surveillance efforts, and management actions. However, all of that data was disseminated through multiple entities or dispersed through multiple entities. And the lack of an all-encompassing summary was a pretty significant problem because it left the full picture incomplete. But before I can truly convey why it's such a big deal that this 50-year gap existed, I'd like to give everyone some examples of how problematic whirling disease can be. In the late 1990s, surveillance and mortality events in Colorado generated a lot of news buzz, given that the parasite near decimated 6 of Colorado's most well-known trout streams. And more contemporarily, similar surveillance and detections resulted in devastation in the Yellowstone River mountain whitefish population. So we saw what this parasite was capable of doing, rendering it even more important to understand its history in the state of Michigan. So with all of that in mind, I developed a question that guided me in addressing that critical agency need, which posed, is whirling disease a contemporary fish health problem in the state of Michigan? So to answer this question, I developed 2 key objectives that focused on the compilation and synthesis of detection, surveillance, and management data with an eye towards developing a compendium of information to be used by fisheries managers. So how did I do that? Like I said before, there was a plethora of information collected over that 50-year span. And with the help of Gary Whalen with Michigan DNR and my own literature reviewing, a folder of over 400 Whirling disease-centric documents was created. And when I say documents, I don't mean Word or Excel documents. I mean scans of handwritten notes, memos, news articles, and just about everything in between. So this was not your modern day literature search, and there really was no Google or Control F to seek out specifics. So this was a pretty hefty undertaking in its own. All right, so picking up where the literature stops, the story I'm sharing today is a synthesis of all of this Whirling disease associated data in the state of Michigan, following that literature that was published in 1972. So we had all of these detections, and what was next? So Michigan DNR set out to treat the stream that was affected in the wild, and this diagram shows one of 5 stream treatments that was done over this time. So in brief, a fish tox kit, antimycin, and a germicidal-free chlorine was released downstream from the infected hatchery, and efforts were made to neutralize the compounds further downstream after it made its way through the areas of the stream they wanted to treat. So I recognized this was an extreme management action, but it was undertaken with the hope and assumption that by eliminating infected fish, and ideally any spores infectious to fish in this one stream, Whirling disease would be eradicated in that wild habitat. So to orient you to this wonderful quality image from 1974, this is essentially a chart depicting when, where, how many, and what species of fish were sampled. And in the last column are the results of the Whirling disease testing following the stream treatments. And unfortunately, spores were found in 2 of the sites that they looked at in both rainbow trout as well as resident trout. And these treatments were deemed unsuccessful. So shortly after this, one hatchery in north central Michigan, namely the Sturgeon River Rearing Station, had fish test positive for Mixobolus cerebralis. But unfortunately, and prior to detection, fish from this hatchery had already been transported to the Platte River State Fish Hatchery. As a result of these detections, the Michigan DNR ordered that over 2 million trout were to be destroyed from these facilities. And perhaps more shocking was my uncovering of the fact that the American Fisheries Society logo hadn't changed in almost 50 years. But back to the fish, this event led to an estimated $10 million economic loss, which translated to over $50 million in 2022. So things were piling up, hatcheries were having to depopulate, and they were finding this parasite in wild streams, and the treatments haven't been working. Concurrently with that, this was generating a pretty substantial amount of media attention. And one quote summarized it up pretty well, though bleak, and they're saying that Whirling disease can no longer be eradicated here. It's become endemic to Michigan, a costly legacy from a single careless transfer of trout. So moving through the continued costly legacy of Whirling disease in the state, the Michigan DNR treated the same stream once more, this time with rotenone. And the results again were unsuccessful, and they found spores in all pools of fish that they processed. So at this point, Michigan DNR shifted their focus to figuring out where this parasite was exactly in the state. So if you're watching these little numbers that I've had pop up in the top of the screen, right here, where I just highlighted the 1990, you might notice that I skipped an entire decade. And that's because in the 80s, there were very limited resources to do this surveillance. So things picked up again in the 90s when they had the ability to look at some of these wild streams. But although those resources were there, they were not infinite. So Michigan DNR developed a simple risk calculator to assess which sites were most worth surveying. So to take you through one example, if a stream had a high salmonid density, a history of Whirling disease infections, and a lot of interactions with Whirling disease positive private facilities, it was given a risk score, and all of these numbers were multiplied together. And for this specific facility that I made an example of, we had a risk score of over 13,000. Whereas if you have another facility where they didn't really have many interactions with positive facilities or pretty low density streams, it had a risk factor of 32, which is significantly lower. So with this in mind, they prioritized a handful of streams and facilities, and they looked at 256 different sites that encompassed 21 private facilities, 11 state and federal facilities, and 56 different rivers and streams. So first, what I'm showing you is a map of the total positive detections by county. And this is what that map looked like following this large-scale surveillance done in the late 1990s. Highlighted in red are counties where it was either detected for the first time or the number of detection events increased. And as you can appreciate, all but one of these affected counties had either whirling disease found for the first time or an increase in whirling disease detection events. So looking at more recent detections, the Michigan State University Aquatic Animal Health Lab came into the picture in the early 2000s. And between 2009 and current times, there have been some additional detections. And again, the counties where detection numbers increased are highlighted in red. And of note, one of these detections was actually in a state fish hatchery and resulted in the depopulation of affected lots. So with all of this information together, what I'm showing you now is a map that shows all of the whirling disease detections in the state of Michigan by county. So every number that you're seeing is a whirling disease detection event that happened in the county. And in summary, I compiled over 130 detections that span 23 Michigan counties and 5 salmonid species. So you might look at some counties and think, man, that's a whole lot of detections. But in this county in particular, where there are 34 positive detection events, this county houses the AFS River, which is one of the most well-known trout streams in the state of Michigan. So whether this detection, all of these detections are a result of it garnering more surveillance attention or the parasite truly being more prevalent there, we don't really know the answer to that. But my data suggests that there have been a lot of surveillance efforts in that county. So I don't know if you remember the timeline that I shared at the very beginning of this slide, this presentation, but it was pretty empty. And what I'm showing you here now is that similar timeline with all of this detection data filled in. So I compiled all of this county information and broke it up by decade. So everyone can see that there is a truly complex history of whirling disease in the state, and it has been a big problem that spanned 50 years. So looking at all of this information together, there are a few exceptionally relevant takeaways. With this data, we for the first time are seeing the ways and sometimes mechanisms from which Myxobolus cerebralis was disseminated throughout the state of Michigan. We're able to paint a picture of the tumultuous 50-year battle this state has fought. And while, as we all know, pathogens can be difficult to defeat, collecting and understanding this data was a critical step to equipping Michigan with critical information needed, such as where it's been found, how common it is on a county basis, and what impact management actions have had. So looking at this data together, you can see counties like Crawford County, like I mentioned, houses some of the most prominent trout streams in the state. And you can also see counties like Lapeer, Washtenaw, Alger, or Ontonagon, all also highlighted here, where I know that these one detection events came from a private facility and were likely a result of fish transfer. But it can be easy to look at those counties and think, man, it's so much more prevalent here. I only need to worry about it here. I don't need to worry about it as much in these counties with only one detection. But I just want to remind everyone that this all started with a single detection in a single county in a single private facility. And this is where we're at now. So shifting gears one more time, an additional part of this project that I've yet to complete is looking at contemporary advancements in whirling disease research to both generate an idea of efficacious prevention or control methods. So like I mentioned before, the Michigan DNR tried these 2 methods. They tried to use fish toxicants and germicidals in an effort to get rid of this parasite in the streams where they first found it. And unfortunately, despite these intense treatments, they were ineffective. However, it isn't all doom and gloom because, as many of you on this call are aware, there are still control options that are widely implemented and effective, including moving away from the use of earthen ponds and the UV treatment of hatchery influent water. Specifically looking at UV, in the state of Michigan, one of our hatcheries that's previously grappled with whirling disease and is also on a stream that has been whirling disease positive in the past, has actually went over a decade without a detection, likely a result of the UV treatment of the surface water. And looking more to the contemporary developments and means of control that have been implemented in other regions of the US or are currently being studied, the good news is that there is some incredible science coming out about Myxobolus cerebralis. There's work being done to introduce whirling disease resistant trout strains, research that's dove further into the intermediate host, Tubifex worms, and uncovered that while the parasite seems to have different effects on different fish, the same is true for genetically diverse groupings or clades of Tubifex worms. And there's also been pretty significant work done to look at how this parasite operates on a more mechanistic level. How does it infect the fish, and how can people potentially intervene to prevent that from happening? And this by no means is an exhaustive list. There are so many papers out there and so many groups doing work on this parasite. These are just a few that I had chosen to show here. So looking at conclusions of this data synthesis project, the first is that whirling disease remains a contemporary threat in Michigan. In Michigan, there's been some push to remove Myxobalis cerebralis from the list of pathogens to screen for prior to some fish movements. And it's debated that this belief stems that because there are no published reports of it in the state within the last 50 years, it's simply a problem of the past. And while it can be easy to think that way as an outsider looking in, following my assemblance of this data, I fully believe that whirling disease is a contemporary threat, and given its spread being at least somewhat facilitated by fish transfer, needs to remain a pathogen of concern, especially when moving fish. Second, and unfortunately, the story of whirling disease isn't uncommon or unique to the state of Michigan. Fish health history shows us that there are several examples where pathogens end up where they are, causing the problems they do as a result of a single decision that had tremendous downstream effects. In the case of whirling disease, a single transfer of infected fish resulted in the state of Michigan being thrown into a 50-year battle of which, despite their best efforts, it will likely never win. And by learning from where things did and didn't work in the context of whirling disease in the state, something only possible when looking at the whole picture, fisheries managers can continue to make well-informed, strategic fish health influence management decisions. So with that, I'd like to acknowledge the Janice Lee Fenske Excellence in Fisheries Management Fellowship for not only affording me the opportunity to take on this project, but also funding my travel to multiple conferences. I have a picture of me here at the Western where I had the opportunity to meet many of the people on this call for the first time. And also I'd like to acknowledge the Michigan Department of Natural Resources, specifically Warren Yoder and John Knapp. And the AFS Fish Health section has the Twitter now, so if you're on Twitter, you should go follow it. And that is all.
Excellent. Very, very well done, Amber.
Thank you.
That was a fantastic presentation. Please put your questions in the chat box, or if you'd rather, just simply unmute yourself and ask directly. We do have one question in the chat box already. Actually, is a couple coming in. We'll start with BBGA, who says, excellent historic review of the disease. They have two questions. One, Amber, do you have any thoughts about eco-environmental factors such as deforestation or ecosystem breakdown that could potentially play a role in the disease manifestation?
Yeah, so one thing that's pretty interesting about whirling disease is that it behaves pretty different in different environments. And at least what we've seen in the state of Michigan, it's been hypothesized in my chatting with Gary Whalen with the Michigan DNR that even slight changes in biotic or abiotic factors can have pretty substantial effects, whether it's how many spores are being released into the environment or what gets turned up through the process of working through streams. So those myxospores are pretty resilient. I mean, in my reading, they can last in places for up to 20 years. So I think that, in my opinion, whenever you're doing any work in streams and you're adjusting that environment or altering it in a way that could be harmful, you run the risk of leading to more of this disease.
They also would wonder if, would it be helpful maybe to differentiate the decades of the study window into perhaps different periods of time, if that would change your analysis?
Like periods of time, like, I guess,
you know, this is over multiple decades. And so if you would look at it into kind of compartmentalized smaller timeframes, I guess. Yeah,
no, that's an awesome point. I mean, I feel like that is like a little bit of how, like when I've looked at the data, I see that too. Like I looking at it in terms of decades, and like I mentioned before, there's no detections in the 80s, but that's not really resemblant of what's all going on. There was still stuff going on with the parasite there. It's just a matter of when they looked for it. So I think that'd be a valuable piece of information to have. And I do have it in terms of when they were looking for it and when they were doing surveillance and kind of looking at those big milestone events as opposed to the years as a whole. So I agree that's a good way of showing the data.
Another question is, could you please elaborate on the current diagnostic and confirmatory testing used to detect this parasite in terms of specificity, sensitivity of tests, latest validation status of these tests, and how does using these different tests possibly impact the comparison between old and contemporary data?
All right, so I don't think I'll be able to tackle every part of that question, but I can go with what I know based on the work that I've done with the Aquatic Animal Health Lab, because we are the lab group that does all of the mixed obelisk cerebrolis testing for the state of Michigan. And I know one of the tried and true ways to first look for this parasite is through the pepsin, trypsin digest process. So basically using those enzymes to break away at the cartilage and release whatever myxospores could be there, and then looking for those parasites or those myxospores via light microscopy. So I know that's somewhat of like the first line of defense for figuring out if this parasite's here or not. And my understanding of it from there is the next step is moving into that confirmatory testing with PCRs. I'm not positive if the PCR currently used is a quantitative or a conventional, or if both are available. But I know what I'm most familiar with in doing is the pepsin, trypsin digest and examination for spores via light microscopy. That's also a relatively accessible and affordable way to do it. I mean, it requires more personnel time, but in my opinion, I don't want to say like gold standard, but it's, again, kind of like the tried and true way of checking for it.
It always feels good to be able to actually see it, right?
Right.
Christine Miller has had her hand raised for a minute, so.
Thank you, Amber. That was an amazing presentation. I really enjoyed it as well. My question's centered around whether or not you're aware or know of any risks to the Great Lakes and establishment of whirling disease within the Great Lakes. Is that a ecologically, I guess, chance, I suppose? Like, is the life cycle or the worm able to work and transmit disease into the Great Lakes?
Yeah, so I mean, it's been found in streams that are in the Great Lakes Basin. So the streams that it's been found in, they aren't all isolated, they do flow in. But what's interesting there is that it could be, like there could be myxospores that are hanging out in the Great Lakes, but what you don't often have in the Great Lakes is juvenile trout. And that's what this parasite really loves to attack, is those juvenile trout and salmonids before their cartilage ossifies to bone. So I don't think it's so much of a question of the myxospores being in the Great Lakes or not, rather susceptible hosts at the right age being in the Great Lakes or not. So I think that's why, or I'd say that's why we see this pop up in the streams, because that's where we have those juvenile salmonids that are hanging out before they head out to the Great Lakes.
Great answer. Thanks.
Yeah.
Thank you all. Amber's up against the clock here, so we're gonna take her off the hot seat, but a virtual round of applause for you, Amber. That was really well done.
Thank you.